Hi guys, this video is prepared for my chemistry students. Before I get into this, I want to apologize for not getting something to you sooner. This whole virus thing has been pretty rough on everybody, and I imagine you probably aren't too sad that I haven't given you extra homework, but I really do want to move forward. Got an email from one of you, and I imagine it's true for all of you, that this lesson is a little confusing. It's a lot of math. I said that at the beginning, and I only gave you the assignment even before spring break, I think, or before the coronavirus, before the Belize trip even, maybe. And then I gave it to you again, and then just only one other one. So I hope this will help you. I do want to move forward, as I said. I don't know how this video is going to go. Excuse me. I'm used to doing math videos. Haven't done a chemistry one yet, so bear with me. And there'll probably be a follow-up video. So I'm sure right now I'm at 1 minute. I don't know how long this video is going to go, so it might be a 15-minute video. It might be more. It might be less. We'll see. Let's just jump into this. So first thing you need to know is this term called a mole. A mole is a measurement of thing, like a counting of things, like the word a dozen or a gross. If I have a dozen eggs, I have 12 eggs. If I have a gross of eggs, I have 144 eggs. If I have a mole of eggs, that means I have this huge number, 6.022 times 10 to the 23rd. That's basically 6022 followed by 23 zeros, an astronomically large number. That number, is given a name, Avogadro's number. Not really important that what the name is, but it is going to be referred to. And the reason they have such this number is for measuring things that come in huge quantities, like atoms. Atoms are so small that if you had this many of them, it would fill up just a small area of whatever it is you were measuring. Okay, and just like and we're going to be counting moles, or we're going to be counting atoms and molecules and formula units and things like that of each of the different elements and compounds. So the first thing you need to know really about moles is that if you look at the periodic table, molar mass is the mass of 1 mole of a given chemical or a given substance. I'm looking in the back of the book at the periodic table, and I see that helium, right below it, has 1.008. 1.008 is the mass of 1 mole of hydrogen atoms. So 1.008 grams is what it is. All of these are in grams. I look at oxygen. 1 mole of oxygen atoms will be 16 grams. Helium, 1 mole will be 4.003. And because each of these is a larger atom, if you have a mole of those atoms, they weigh a little bit more. And having these molar masses from the back of the book or from your periodic table, wherever you get it, page 117, is crucial for these problems. So I'm looking at the very first example on page 225, and it says, how many atoms are in 4.5 moles of a sample of helium? Okay, well, we're not dealing with the mass in this one, but I wanted to get that out of the way. So if I have 4.5 moles, and I'm just going to use the letter M for mole, of anything, whether it's helium or hydrogen or eggs, 4.5 moles of eggs, how many atoms do I have? Well, I have to multiply, and I'm going to use a unit multiplier. If you're not familiar with unit multipliers, you should have paid more attention in my math class. That's all I have to say, okay? Because we remember that anytime you have things that are equal, you can set up a unit multiplier. I'm going to put I'm going to put 1 mole down here, and 1 mole is same as 6.022 times 10 to the 23rd. And I just simply multiply those out and put it into scientific notation. So I'm just going to say 4.5 times 6.022 equals, and I get 27.099 times 10 to the 23rd. They want this in scientific notation. In scientific notation, the decimal has to be right there. They move it 1 over, and that'll give me 2.7099 times 10 to the 24th. Okay? And I think the book just says 2.71 times 10 to the 24th. The reason it goes up 1 is this became 2.71 times 10 to the 1. And I add it to the 10 to the 23, and I get 10 to the 24. They could have just said the same thing. If I had 2 moles of helium, well, I would just multiply 2 times 6.022. If they had 11 moles of anything, I'm going to multiply it by 6.022. They get into the molar mass in the second section, and they go to the second question. On middle of page 226, it says calculate the mass of 0.5 moles of helium atoms. Now, when they ask anything about mass, you're always going to have to refer to your periodic table. I'm going to change this. Let's say it was 2 moles of helium. How much does 2 moles of helium weigh? A lot of times I'll write it as 2m, but that also stands for meter. So I think I'll go with MOL or just MOLE. You're only losing 1 letter. It's not much of an abbreviation. Excuse me, my mother came into the room and didn't shut the door, and now she's clanging around in the bathroom. In the kitchen, so it's a second. Okay. Sorry about that. I'm in Missouri with my mom. So, if they had said 2 moles, and what is it? Helium. And I need to find out how much 2 moles of helium weighs. Well, I know that 1 mole of helium weighs 4.5. No, sorry, I'm wrong. That was for the first problem. I go to the back of the book, and I find out what 1 mole of helium weighs. 1 mole of helium weighs 4.003. It weighs 4.003 grams for every 1 mole. And they'll often put HE. 4 grams of helium gives you 1 mole of helium, or 1 mole of helium gives you 4 grams of helium. Which do you put on top? Well, we are changing from moles into grams, so I have to do this. So that would give me 8.006 grams of helium, because this unit multiplier of mole here and that unit multiplier of mole there would cancel. Now, the book didn't ask for 2, it asked for 0.5 moles of helium. Well, you're going to do the same thing. I'm going to multiply by 4.003 grams of helium over 1 mole of helium. Now, I know some of you might be able to do this in your head. You go, oh, that's just half a mole. Yeah, just divide by 2. I greatly encourage you to show the unit multiplication on this. And what is that going to be? 2.0015. I don't know what they have in the book. They just say 2.002. They round it up. And again, this mole and this mole cancel. Okay? So, repeating myself, and I will, just like I do in math class, so you remember it a lot, I'm going to repeat myself a lot, saying you always have to refer to the periodic table to get this information. So let's go to example 9.3 in your book. It says, how many atoms are in 33.3 grams of gold? Okay? In almost all of these problems, you have to, whatever they give you, you have to find out how many moles there are first. Okay? Well, they do you a disservice in this one. They say 33.3 grams of gold. Okay? Oh, no, they say milligrams. Well, the molar masses in the back of the book are all in grams. I wish they hadn't done this to you. In fact, let's just switch this up. Let's say how many moles in 5? Or let's do 500 grams. Let's be bold. 500 grams of gold How many moles is that? Okay, well, I know that 1 mole of gold, and now you'll notice I've got moles on top and grams on bottom because I'm converting out of grams. Well, I don't know. How much does gold weigh? 1.97 grams. I've got notes written here, and I don't know if it's 1.97 or 197. Probably nope, it's 197 grams. So if 197 grams gives me 1 mole, how much will 500 grams give me? I always take what they've given me. I've got 500 grams in my hand. Wish I did. How many moles will that be? So the grams will cross out, and this is 500 divided by 197. That will give me, 2.54 moles of gold. Now, the question says, how many atoms do you have? Well, I've got 2.54 moles. How do I change that into atoms? Well, I know that 1 mole is equal to 6.022 times 10 to the 23rd. So I've got this 2.54, 2.538, blah, 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 in my calculator. I'm going to multiply it by times 6.022. That'll give me 15.28 times 10 to the 23rd atoms. By the way, I didn't say this earlier. This could be 6.0, well, I didn't write it. This could be 6.022 atoms. It could be molecules. It could be eggs. We can count anything in that, but we're not going to count eggs or shoes in that. We're always going to count atoms or molecules. Okay? So I've got this many atoms. That's not in scientific notation. They move the decimal over to get 1.5, I believe it is 53 times 10 to the 24. Okay? Now, the book didn't ask about 500 grams. They asked about 33.3 milligrams. The first thing we got to do is change 33.3 milligrams into grams. How do you do that? Milligrams is what we're changing out of, so milligram has to be on bottom. Gram has to be on top. If you didn't know that, know this. There are 1,000 milligrams in every gram, but the 1,000 goes on bottom. When I was doing this in preparation, I put the 1,000 on top because I wasn't thinking. Okay, so that's 33.3 divided by 1,000. The book gives it to you in scientific notation. They give it to you as 3.33 times 10 to the negative 2, I believe. I'm going to just put it in whatever my book says, not whatever my calculator says. 0.333 grams. Now, that's of what? Of gold. So I have just, first of all, I had to convert that into grams. So if I have 0.033 grams of gold, what am I going to go do? I'm going to find out how many moles of gold I have. Well, 1 mole of gold, just like I did up here, when I had 500 grams of 500 grams of gold, I multiplied by this unit multiplier. 1 mole of gold over 197 grams of gold. Okay? This is going to be a really small number. This is 3/100ths of an ounce. And we're dividing by 197. That's going to be really bad. And I think I did times 197. Let's do it again. Divided by 197 equals, yeah, there we go. Divide by 197 equals again. And I get 1.69 times 10 to the negative 4. That will tell me how many moles I have. They haven't asked about how many moles, they've asked about how many atoms. Well, now I'm going to multiply that by, by the way, this is moles. Well, how many atoms is 1 mole? Well, it's 6.022 times 10 to the 23rd. So I'm going to take this and I'm going to go times 6.022 equals, it gives me 1.02. And in my book that says, my calculator says 10 to the negative 3. That did not take into account that 10 to the 23 up there. So this will eventually give me 6.02 times 10, that's a 10 there, to the 20. I better check the answer. Yep, it's so small, I'm in a dark room. Yep, 1.02 times 10 to the 20. Now if you look in the book, they do this all in one long line. They don't put an equal sign here and then do another one, then put in equals and then do another. To do it all in one string. That's great if you're really on your toes. I like to show it as I go along. And there's that. We're already at 16.5 minutes. I'm going to stop for now. I'll have another video for you later. We'll continue with this lesson.